So one thing I didn't finish from the previous video, if the overflow flag, the rule for the carry flag, exclusive or carrying to the most significant bit is too complicated for you. Here just a simple rule, how you will see the overflow flag will be set. They have only two situations. The first thing, if you have two positive operands, but you add, the result become negative, then overflow flag is set. Because the overflow, the value is not enough to hold. Or you have two negative numbers add together, but the sum become positive. Both two situations cause the overflow flag is set. But overflow flag actually is never being set if the sign of two addition operands are different. So they never happen because they can cancel each other. So that's why you can check these two examples to see how the overflow flag results. When you have these two numbers, they are negative and positive. When they add, never will have overflow flag is set. Okay, so that's the about the overflow flag and carry flag. And of course, we have so many different examples. So please make sure you will work on the peer talk. If you have questions, the result you're not sure, we will talk about in the Zoom meeting. So the next one, let's go over the last section. So this video we will just show you a couple important operator. Yeah, so then this one is work with the data related operator. So we have few of that. We have offset to know the memory location for the operand. You have PTR to save the operand memory location. So then you have type operator to know what the size of the operand. Then you have length of, size of, that's work with the array. So we see what is the offset. So offset operator return the distance in byte. So on the other hand, our distance, of course, our bytes start from 0. So then the offset is the distance in byte of the label from the beginning of enclosed segment. So that's why, of course, when you have the offset, they will return you the memory location from that segment. So for the protected mode, we're using 32-bit. In 32-bit environment, the real address mode is 2 byte. So that's the offset. So that's why you see here, we just assume the data segment begin at this value. So then you will see here, we have the a byte variable, word variable, D variable, and the V2 variable defined. Even we don't assign the value. Okay, so then when we try to get offset, so that's why you will see, because you see this one, right? You declare one by one, but here in the memory, they just look at this way. They look like this, okay? So you have your B value, we point to here. So that's 1 byte. So here we have 1 byte occupied. So then you see, then you have another one, so 2 bytes. So here I don't try to enlarge the size. I just write down how many bytes they assign. So then D word is 4 bytes. So then here on D word you have another 4 bytes. So that's why here you will see, let me write. Yeah, I think this way is easier to see. We just know, for example, here at this point we start from 440040400. Okay, so after you add 1 byte, so then of course they'll change. But this location, when you start, that's the B value locate. So if you use the offset, they will have the address return. Then you need to save the value. So that's why we move the value to ESI. So that's why ESI will have the location. So then you see this one is the B value. So then plus 1, they will be the beginning of the W val. So that's plus 1. So then continue, that's 2 bytes, right? So then you have D value. So then you plus another one, become this. So then you have the last one, your D value 2. So that's the value here. So that's how they look like. So you will see offset, they will return the memory location for the segment. So after you get offset, because that's in the protected mode, so the address will be 4 byte. So after you get offset, you can save in any 4 byte location. So that's also bring us is we can have a variable is we call that a pointer variable. The variable contain the address of another variable is called a pointer. So you can declare a pointer variable that contains the offset of another variable. In 32-bit environment, of course, the address will be 32 bits. That's 4 bytes. So we see how we will use that. You see, for example, you have your array W declared. That's the data label. That's the data type. So then you have 3 values. So then we can declare a pointer variable. So this pointer variable always is 4 bytes. So that will be D word. So then when you have a pointer variable, you call ptrw, right? So then you see the D word. Then remember, so you declare the D word, right? Then you give them the label name. But remember, label name actually just contain the address. So on the other hand, now the ptrw just purely have the location for the array W. So basically, when we do this way, you do in the data declaration. You can do this way, just have array W. But this one actually is exactly the same. You say offset array W, then you save in the ptrw. So afterward, you have the ptrw actually just a pure location, right? So this pure location, actually, you can just access that to the reference as well. Because ptrw itself is only the memory address. So if I want to using this memory address to access the data, right? So that's why you see here. This one is the location, right? In this location, array W contain 1000H. So the same thing, your ptrw refer to this location. But ptrw itself is holding the address. So in order to dereference the value, remember we show you in the Tuesday video. If you want to dereference the address, then you can use in the square bracket. So then here you will see they will move the ESI location to the AX. So ESI only have the location for that memory address. So then because you move to AX, they know they will read for 2 bytes. So that's why now AX have value is 1000. So that's the PTR on the pointer, actually the pointer variable, how they declare in assembly language. Very similar to C++, the asterisk symbol, but we just need to declare it's a 4 bytes variable. So you can see compared to C++, how we will do in the pointer syntax, but in the assembly language, it's just purely to using the offset and make this offset to save in a 4 byte address, 4 byte location. So then we will save the memory address. So that's for the memory address. So even you have your offset, we save the location. But one thing is when they want to move or operate to another location, you see, because this one, the location you point to is array W. Array W defined as the word. So we only can process this location read for 2 bytes. So that's 2 bytes. When you move, you need to move 2 bytes as the AX is registered. But sometimes if you know that location, but you want to read differently instead of the default declaration for the word, so we introduce you another pointer we call, another operator we call PTR. So this PTR actually is override. So you will see the PTR operator, they will override the default type of a label, provide the flexibility to access the part of the variable. What does that mean? So the syntax is the type before the PTR. Then you have your label name. We see the example for like here. In the data, we declare my double is the D word. So that's 4 bytes. So I have 1, 2, 3, 4, 5, 6, 7, 8. So remember, even that the whole thing is 4 bytes, right? We told you by byte, they will write in the little endian order. So now, here we want to show you. Supposedly, if you're only using my double, right? You want to move to the AX is incorrect. Because move, when you have the move, the two operands need to resize in the same memory size. So my double default is 4 bytes. So they cannot move to AX. But now, since we have the type PTR name, then I can do is what? I know my double, actually the location is here. Now my double actually point to the beginning of this memory location. So if I only want to read the 2 bytes here to save in AX, so what we can do is I just use the PTR operator. So the PTR operator followed by the label name. So then to tell me from this point, how many bytes you want to read. So I want to read 2 bytes, right? So right, I have the type word before that. So that's why after word, we have the 5, 6, 7, 8 right in the AX. So not only you can have your word PTR in the source operand. So the same thing, if I want to change this last 2 bytes, I can using the move word PTR, my double, I point to here. But then I overwrite. So I write 4321. So that's why that's a little endian, right? So that's 21 is here, 43 is here. So afterward, your my double will read as 1, 2, 3, 4, 4, 3, 2, 1. So that's the PTR operator. So they can flexibly to access part of the variable. So continue use the my double to see how many bytes you want to access, right? But how about I just want to access the 3, 4. I want to change this location. So actually we can do that. Because like earlier we say, your my double is referred to the D word like this. So then if you have word or byte, they are referenced 4 byte like this, 2 byte like this, and 1 byte. But here remember, my double can look like this way. My double here, then my double plus 1, plus 2, plus 3, that's referred to different location. So that's why, for example, here, if you only want to access the 5, 6 into this value to read, to save in AL. So you can do is you move AL, then you do the byte pointer. So you need to using my double this location to read 1 byte. So that's how you will change the value. So the same thing, if you want to only read 1, 2, 3, 4 to the AX, so you need to start from my double plus 2. So then you see you do the PTR word. So then you move to AX. So the AX will become 1, 2, 3, 4. So that's the PTR operator. So we didn't go over each one. So make sure you will go over one by one to make sure you understand the result is correct. And also we have more example here. So make sure you will post the video and check your result. Is that correct answer? If you have question, we will talk about during the Zoom meeting if you cannot figure out the result. Okay, continue. We have 3 more operators. That will be just definition. One is type operator. The type operator returns the size in bytes for the single element. So for example, you have val1, val2, val3, val4. They are byte, word, and D word, and Q word. So then you see if you do the type, val1 is byte, so they return 1. So then you save in EAX. So the same thing, so type val4, that will have the quarter words, that will be 8 bytes. So they will return how many bytes in the variable. So that's a type operator. Then we have the length operator. They will count the number of elements in single data declaration. For example, you see here you have the array 1. So this array 1, you have 130 duplicate, then 0, 0. So total they have 32 elements. So the length of, they will return 32 elements in the ECX. So the length of is how many elements after the data label. Then you have size of. The size of actually is return the data label for the equivalent size, so in byte.